Magnetic resonance imaging, or MRI, uses very strong magnetic fields and radio frequencies to have an effect on the particles within the human body. Those particles include protons and neutrons within each atom. Now, not every atom has an effect or is affected in an MRI scan, and we'll see why that is. The technology has been around or investigated since the mid to late 1940s. However, it wasn't until the late 1980s, that MRI was producing images that were high enough resolution to be used in diagnosis. The advantage of MRI over CAT scanning is the MRI does not produce, is not using ionizing radiation, which can damage tissues and DNA in the body. And it also produces an extremely high resolution image, as you can see the two images here. And it also produces images of both soft and hard tissues. So we've got bones here, we've got spinal cord, we've got brain tissue, the tongue, and you can see a variety of tissues there. The image can be coloured to draw attention to other problems. So you can see the image on the left is healthy tissue. The image on the right has a tumour, and that's just been coloured to make the area of interest highlighted. This is a brainstem tumour that, if not treated, will cause probably death to the patient. Like CAT scans, MRIs show slices through the body. The images are tomographic or tomography. And as I said, they can show both soft tissues and bone. The MRI is the highest quality image that we have, and it's produced from within the body. So we're not relying on radiation from outside passing through the body as in the CAT scan using X-rays. This one uses the magnetic field to affect protons and neutrons in the body. But and it also uses radio waves to cause them to release a little bit of information or energy themselves that we can then trace and image. MRIs involve the use of very powerful magnetic fields, and you can see there's a whole host of images on the web, and you need to keep, because there's such a strong magnetic field emanating through this machine, you need to keep any materials with iron or ferromagnetic materials away from them in separate rooms. You even need to keep these machines apart. So some practices that have MRI machines, more than one, will put one in another location, either far enough away that the magnetic field does not affect the other machine. And you can see the damage caused here by the machine. And here's a chair that was left in the room, perhaps when a technician turned the machine on. The machine also has indicators and is connected to the internet to keep track of coolant levels, often liquid helium, which has to be monitored in order to create a very powerful magnetic field. So major hospitals all use MRI machines. A lot of private practices also use them, and private clinics. You can see this is quite a long time ago, but there were quite a few machines, so there's now a substantial increase on that number. We get excellent images from MRI. Some MRI machines also help us to diagnose diseases that up until the use of MRIs has been difficult. It might not show up on a PET scan as well, but and a structural imaging device like a CAT scan might miss because of the lack of resolution or lower resolution than MRI. Remember, resolution is just the ability to show or define the difference between 2 points. So higher pixels, higher number of pixels, etc., or voxels as they're called in MRI machines. The MRI machine itself, if you think about a coil, and we have the right-hand grip rule of this coil, if the current is going up and round over this coil and then back out, it forms a north at this end. Well, if we lay a person in an MRI machine, and they're inside the actual tube of the machine, around that person we have our magnetic coils, and they're cooled so that they become superconductors, superconducting coils. And those superconducting coils can produce enormously strong magnetic fields. The radio pulses and radio waves that are used, of course, are produced by smaller coils. And we'll see that later on when we look at how an MRI machine works. But essentially these magnetic fields affect the protons and neutrons in the human body. We do have a disadvantage of MRI. That is that sometimes people can't use it with materials that might have in their body that are magnetic or ferromagnetic. A large magnetic field can cause induction of a current, so some people can't use. Get currents induced. Some metals. And the main reason not to have an MRI machine, maybe in the country or in a town, or small town, small city, is it's very expensive. Things such as the helium that's used to cool these superconducting coils has to be monitored. And new helium has to be used to fill the machine if the levels are lower. So the expense is the main thing that drives down the use of the MRI machine. But they are very useful because of their high resolution. So there are these advantages that tend to outweigh those disadvantages. People in more remote areas might go to towns that are nearby to use the MRI machine or MRI facilities.